So this video here is going to go through the Module 1 constructed response review. What we want you to do for this is actually go through, make sure you have all of these answered, and then we're going to give you a space where you can upload some pictures of the problems here that we're going to go through. Alright, so for this one here, I'm also going to break it down where each problem, you'll be able to click in the description to go to the time where that problem starts in the video, because this might be a long video here. So the first one says, the expression 2L plus 2W is used to find the perimeter of a rectangle with length L units and W with W units. Name all of the terms, coefficients, and variables in the expression. So we have three vocab words here: terms, coefficients, and variables. So we start with terms. Terms are anything that we have that is being added together in an equation here. So when we take a look, or subtracted, when we take a look, 2L is one term, and then the other term in this equation is 2W. So they're separated by addition, which distinguishes each of those terms there. Coefficients. Coefficient just means, right, the number in front of a variable. So our coefficients in this expression there is the number in front of L, which is 2, and the number in front of W, which is also 2. So our coefficient for both of those is just 2. Then variables, right? Variables are our letters that we use to represent unknown numbers here. In this case, our variables were L and W. L stood for the length, W stood for the width. Then part B down here says it wants to rewrite this expression using factoring. So if we have the expression 2L plus 2W, if we want to rewrite that using factoring, we have to see what do both of these terms have in common. Here they both have a 2, so we can rewrite this by dividing 2 from both terms, moving it in front of set of parentheses. Then what we're left with is L plus W. So 2 parentheses L plus W is an equivalent expression to the original one they gave us. However, it is factored out the 2 there. Part C says the equation 70 plus 2L plus 2W can be used to find the length and the width of a rectangle with a perimeter of 70 units. So the first thing here, C says to solve this equation for W. So when we're solving an equation for W, right, we're isolating W as the variable. So we have 70 is equal to 2L plus 2W. So if we want to get W by itself, the first thing we have to do is remove the term that's being added with W. So that here is our 2L. So we subtract 2L, and we subtract 2L from the left side as well, because what we do to one side of an equation, we must do to the other. So then on the left side, we have 70 minus 2L is equal to 2W. Again, we want to get W by itself. So what we need to do is the opposite of what's happening here. So this is 2 multiplied by W. We want to do the inverse of multiplication, which is division. So divide by 2, divide the left side by 2. On our right side, we have 2 divided by 2, which turns into 1, which leaves us with just 1W. And then on the right side, we have 70 minus 2L divided by 2. So this equation is solved for W now. However, we can simplify it a little bit because 2 can go into both terms here. So 70 divided by 2 is 35, minus 2 divided by 2 is 1L, and that's equal to W. So when it said here to solve the equation for W, we did that there, and it is 35 minus L is equal to W. Taking a look at question 2. So 2 says that 2 inequalities are shown below. So we have the inequality negative 26 is less than 4k minus 2, and 2k minus 1 is less than 5. So here it says write a compound inequality to combine the inequalities above. So in order to write a compound inequality, we need to have something similar that we can combine together here. So when I look at this 4k minus 2, it's similar to this 2k minus 1 because it is a multiple. It's like if we took this 2k minus 1 and multiplied by 2, we would get 4k minus 2. So if we want to change our inequality on the left side, what we can do is divide both sides by 2, and we'll get a new inequality that's equivalent to the first one we had. So negative 26 divided by 2 is negative 13, which is less than 4k divided by 2 is 2k. Negative 2 divided by 2 is negative 1. Now, since this matches up with our other inequality, 2k minus 1, we can just continue this inequality and say that negative 13 is less than 2k minus 1, and 2k minus 1 is less than 5. So in order to create our compound inequality, we manipulated one of the inequalities to set it and be able to get it there in the middle. Now, the other thing we could have done is multiply this whole inequality by 2, right? So if we multiplied this whole inequality by 2, we would have 2 times 2k, which is 4k. 2 times negative 1 is negative 2, is less than 2 times 5, which is 10. And we could have written it as negative 26, less than 4k minus 2, which is less than 10. So that's another way we could have done it there. Now it says to solve our inequality for k. So for solving the inequality for k, we set up our two inequalities. So negative 13 is less than 2k minus 1, and 2k minus 1 is less than 5. Now we solve it using our same rules that we use to solve equations. So we want to get k by itself. So in our first inequality, we have to remove this minus 1. So we add 1 to both sides, plus 1. Negative 12 plus, or negative 13 plus 1 is negative 12, which is less than 2k. Now we have 2 multiplied by k. So to get rid of that 2, we divide by the coefficient, which is 2, divide by 2. Negative 6 is less than k. So now we've solved half of it. Now we have to solve the other half over here. So we're going to repeat similar steps. Our first step is to add 1 to both sides. So these will cancel out and we'll have 2k is less than 6. And now to get k by itself, we divide both sides by 2. Divide by 2. K is less than 3. Now if we want to combine these back together, we can write our solution as negative 6 less than k, which is also less than 3. Now, part C here says to graph our solution on the number line below. So remember, when we're graphing inequalities, when we have less than or greater than, we have an open circle. And when we have less than or equal to or greater than or equal to, we have a shaded circle. So for this one, it's going to be 2 open circles, one at negative 6. So if we look on our number line, we have 0, negative 5, negative 6, and then one at positive 3. So 0, 1, 2, 3. Then our k is in between these 2 points here. So k is all the values in between negative 6 and 3, but it does not include 3. So for part D, it says that Jamie says that k is equal to 6 is a reasonable solution to the inequality. Explain why Jamie thinks that and why he is incorrect. Well, first, when we take a look here, one reason he might think this is because if you look at just one of these inequalities, like the first one here, it says that negative 6 has to be less than k. Well, if we just had negative 6 and then Jamie's number of 6, this would be a true inequality. However, in this problem here, it has to meet both of these conditions. It has to be greater than negative 6 and less than 3. So why he thinks that? So 6 is a reasonable solution to the first inequality. However, it does not or doesn't work for the second. So it's a reasonable number for the first inequality, but not for the second. So therefore, it doesn't work for this compound inequality. All right, moving on to question 3. So question 3 says that a manufacturer makes rectangular blankets in several styles and sizes. The outline of a popular blanket in size A is shown below. So we have a blanket here. We have it as a rectangle. So in a rectangle, you know that opposite sides are equal. So that means our top is 3x plus 7 centimeters. And then also our side here is 2x minus 3 centimeters. It says to write a polynomial expression in simplified form that represents the perimeter of the blanket. So what it wants us to do is add up all the sides, which will give us the perimeter. So what we can do for the perimeter, we can also say the perimeter is equal to 2 times the length plus the width. So we can pick two sides and write them, add them together, then multiply by 2. So here if we're taking 2 times the length, which is 3x plus 7, plus the width, 2x minus 3. When we combine like terms, we have 3x plus 2x, which is 2 times 5x, then positive 7 minus 3, it's going to be positive 4. We distribute the 2 times 5x is equal to 10x. 2 times 4 is equal to plus 8. So this is our simplified polynomial. 10x plus 8 is our perimeter. All right, and it said write a polynomial expression. So while I wrote the equation for perimeter at the beginning, our final answer is an expression with no equal sign. Moving down to part B, says write a polynomial expression in simplified form that represents the area of the blanket. So remember, area is length times width. So now, instead of adding up all the sides, we're going to multiply 2 of the sides together here. So we take the length, which is 3x plus 7, and then we multiply it by the width, 2x minus 3. So this is where we're going to do the distributive property 2 times. So I'll get some different colors going on here. So we start with 3x times 2x. So we do 3 times 2, which is 6. Then x times x is x squared. Then we're going to multiply 3x times negative 3. 3x times negative 3. We do 3 times negative 3, which is negative 9. And then we add in our x there. Now we'll move on to a different color here. Multiply our second term in our first binomial. So positive 7 times 2x is going to be positive, we'll line this up here, positive 14x. So notice how I lined the x's up next to each other. Then positive 7 times negative 3 is negative 21. Then we draw our line to collect like terms. So first we have 0 plus negative 21 is just going to be negative 21. Then negative 9x plus 14x is positive 5x. Notice how our exponents with our x doesn't change. None of those x's canceled out, right? We're just adding the coefficients or the numbers in front. And then 6x squared just comes down, 6x squared. So our final answer for an expression for the area is 6x squared plus 5x minus 21. So now we go through and we take a look at part C. So here it says that the same style blanket in size B has a width of 2x plus 10 and a length of 4x minus 10. So that's size B. says, write a polynomial expression in simplified form that expresses the difference in area of blankets A and B. So we're going to take the difference of area here, right, of A and B. So we start by finding the area for size B. So size B, we are given two dimensions, the length and the width. So we're going to multiply these two together. So we're going to take 2x plus 10 multiplied by 4x minus 10. Now when we go through, we can use our two different colors here to show when we multiply the first term. So 2x times 4x, we multiply the coefficients, 2 times 4, which is 8, x times x, x squared, and 2x times negative 10, multiply 2 times negative 10, which is negative 20, and we have our x. Follow that up with multiplying our second term, 10 times 4x, it's going to be positive 40x, then 10 times negative 10, negative 100. We come down and we collect our like terms. So we take 0 plus or minus 100 is negative 100. Negative 20x plus 40x is going to be positive 20x. Then we take 8x squared and we just bring that down as well. So if we're looking for, or sorry, this is actually, yeah, so this is correct. All right, so if we want to go through here and find the difference, right, we subtract the two widths here. So we have our style A, which is up here, and our style B, which is down here, and we're going to subtract them. So we start with our style A, which is 6x squared plus 5x minus 21. And we're going to subtract from it. I'm going to put in parentheses here. 8x squared plus 20x minus 100. So now when we go through, we're going to change this. Instead of subtraction, we change it to the addition of the opposite. So we'll have 6x squared plus 5x minus 21 plus negative 8x squared plus negative 20x, then plus positive 100. Then we can go through and collect like terms. So we could start with our x squared. So we have 6x squared plus negative 8x squared. So 6 plus negative 8 is negative 2 x squared. Then we can take our next term, the x's. So positive 5x plus negative 20x. Positive 5 plus negative 20 is going to be minus 15x. And then finally, our last one we have here, we could take negative 21 plus 100, which is going to equal positive 79. So the difference between these two blankets here is negative 2x squared minus 15x plus 49, and these are centimeters squared. So to find this one here, we found the area for blanket B, all right? We subtracted the area from blanket 1, or blanket A, and we found the difference to be negative 2x squared minus 15x plus 79. Lots of work in that problem. Just make sure to, when you're multiplying each term in both parentheses, right? So we had 4 multiplication problems. And then also when we're subtracting, we make sure that we change the sign of each term in our second expression. All right, moving on to question 4. So question 4 says that Padma rented a bike for X hours and a kayak for Y hours while she was on vacation. Padma rented the bike and kayak for a total of 7 hours. Write an equation to represent this situation. So now we're getting into writing equations. Our first equation here, if we want to find the total number of hours, we take the hours she rode the bike, so X, plus the hours she rode the kayak, Y, and that equaled 7. So that equation was kind of easy. All right, and when we go on to the next one, it's going to get a little bit more complicated, but it's going to give us our second equation we need to work with this system of equations here. So the second part says the bike costs $6 an hour to rent. So if I'm talking about the bike, it's $6 an hour. And the kayak cost $10 an hour to rent. Padma spent a total of $60 for the bike and the kayak. So remember, the bike, we said, was our X, and our kayak is our Y. So if we're writing these equations out now, we're going to have to write the amount it costs per hour times the number of hours, which is X. So 6X for the bike plus $10 times Y, so 10Y for the kayak equaled 60 total dollars. Next, it says, how many hours did Padma rent the kayak? So if we're looking for the hours of the kayak, right, we can look at our top here that the hours for the kayak is going to be our Y. So we have two equations now, X plus Y equals 7, and 6X plus 10Y equals 60. So now what we have to do is set them up and solve for solve our equations for Y. So we have X plus Y equals 7, and we have 6X plus 10Y equals 60. So what we want to do is find out what Y equals, which is the amount of hours. So if we go through here and we're trying to solve this equation for Y, what we can do is manipulate our equations so that our X's cancel out. Then we can use the elimination method to solve for Y. So if I want my X's to cancel out, I need the coefficients to be additive inverses. So I need them to be opposite signs, but the same number. So if I want to change X plus Y equals 7 into something that cancels out with a positive 6X plus 10Y equals 60, I need the coefficient for my X here to be negative 6. So in order to do that, what I'm going to do is take X plus Y equals 7 and multiply this whole equation by negative 6. So it'll be negative 6X plus negative 6Y equals negative 42. Now I'm going to combine this equivalent equation with one of the original equations we have to solve for Y. So I'll start with negative 6X, then we can do minus 6Y equals negative 42, and combine it with 6X plus 10Y equals 60. So then if I'm solving for Y, the X's will cancel out, and then I'll have negative 6Y plus 10Y, which is 4Y, is equal to, then negative 42 plus 60 is going to be positive 18. Go through, divide both sides by 4, divide by 4. Y is equal to 4.5. So here, the amount of hours that she rented the kayak was 4.5 hours. Now, if we want to keep going here, we could find out how many hours that she rented the bike. It doesn't ask us to here, but in this type of equation, or in this type of example, we're often asked to. So if we want to do that, we would take our original equation, X plus Y equals 7, and substitute in 4.5 for Y to solve for X. So X plus 4.5 equals 7. Then if we're solving for X, we subtract 4.5 from both sides. And we find that x is equal to 2.5 hours. So the amount of hours that she rented the bikes was 2.5, but the amount that she rented the kayaks was 4.5. So now if we continue on, it wants us to graph a system of equations that we wrote in part A on this coordinate plane here. So we could start by taking our two equations that we had, right? So we had x plus y equals 7. And we also had 6x plus 10y equals 60. Now to graph these on our x and y axis here, we want to first solve each one for y. So our first equation is a little bit easier. To get y by itself, we just subtract x from both sides, and we'll have y equals negative x plus 7. This will be our first equation we graph. And our second equation, do this one in a different color here so when we graph it we can see. A little bit more work. First we divide both, or subtract 6x from both sides. So we have 10y is equal to negative 6x plus 60. Divide both sides by 10. Divide by 10. Divide by 10. We have our second equation. Y equals negative 6 over 10, which simplifies down to negative 3 over 5x plus 6. So now if we want to graph these two equations on our axis here, we can start with the first one. So when we take a look at this, we want to look at the slope. For here, our slope is negative 1, which is negative 1 over 1, and our y-intercept is positive 7. So we start at 7, and then if our slope is negative 1 over 1, we go over 1, down 1, over 1, down 1, and we continue going through. Then we can connect these with a straight line here. And this was our line x plus y equals 7. Now if we want to graph our second equation here, we have to start at the y-intercept, which is 6. And now this one we're going to go down 3 to the right 5. So down 1, 2, 3. To the right, 1, 2, 3, 4, 5. Down 3, 1, 2, 3. To the right, 5. 1, 2, 3, 4, 5. And we have our straight line here. Well, let's see if I can get a little bit straighter. That one looks a little bit better. And this was our line 6x plus 10y equals 60. Then here it says, explain how we can use this graph that we made to check our answer for part C. So remember, our answer for part C, we're looking for the intersection of these two graphs here. So where these two graphs intercept, with our x being the x being the hours of the bike. So this was the bike hours, and the y being our kayak. So if you go through here, and take a look at 2.5, these lines, so my line's a little bit taller than where it should be, but at 2.5 and 4.5 is where these two lines intersect. So where they should intersect there is 2.5, 4.5. Remember that our x was our hours of bikes and the y was the hour of kayaks. So that's how we could use a graph to solve that equation as well. All right, and then if we're putting this into our calculator, we can also check it. Going to our calculator, enter, right? We can go through, let's do new document. We want to do a graph. The first one we want to put in is f of x, or y, is equal to negative x plus 7. We get our line. The second one we want to do, so we hit tab, insert our second equation, which is y is equal to control divide -3/5 x plus 6. We can see those two lines intersect. If we want to find that intersection, we hit menu. Then we want to analyze the graph, choice 6. We want to find 4 in the intersection. And then on the lower bound is on this side of the intersection. We click. We want the intersection to be in the middle there. And we see that they showed us that the intersection was at 2.5 and 4.5. So our x value of 2.5, y value of 4.5. All right, taking a look at the next question here. So the next question jumps in. Question 5 says, Vic and Ava buy used cars at the same time. Vic buys a car with 10,000 miles on it. He drives it an average of 100 miles a week. The equation below can be used to determine how many miles M will be on the car after any number of weeks of driving W. So M is the amount of miles after the amount of weeks of driving. And how many weeks will Vic's car have 1,000 or 12,000 miles on it? So if we want to find this, all right, we're looking for the weeks, and we're given that M is equal to 12,000. So we're going to use our formula, M equals 100 W plus 10,000, and substitute in the known value of 12,000 for M, and then solve for W, which is the number of weeks. So we substitute 12,000 in, so 12,000 equals 100 W plus 10,000. If we want to get W by itself, first we have to remove this 10,000, so we subtract 10,000 from both sides. 12,000 minus 10,000 is 2,000 is equal to 100 W. Then to get W by itself, we divide by 100, divide by 100, and we get that W is equal to 20. So our answer here is 20 weeks. Next part here says that Ava buys a car with 7,000 miles on it, but she drives it an average of 400 miles a week. Use the system of equations below to find out how many weeks Vic's and Ava's cars will have the same number of miles on them. So, and how many weeks will they have the same number of miles? So we want to find out when the miles are equal to each other. So when we take a look here, they gave us both equations in terms of M. So if we want to solve this system of equations, we can use the method of setting them equal to each other, or substitution, in order to solve them. So instead of having both of these equal to M, we can set them equal to each other. So I'll start with 100 W plus 10,000 is equal to 400 W plus 7,000. So since they're both equal to M, we can set them equal to each other and then solve for the number of weeks. So if we're solving for the number of weeks here, first thing we want to do is get the variables to one side of the equation and the numbers to the other. I'm going to subtract the smaller variable from both sides, so minus 100 W from both sides. That will cancel out to 0 over here, and we have 10,000 is equal to 400 W minus 100 W, which is 300 W plus 7,000. Now we want to get W by itself, so we have to subtract the numbers with the W, so minus 7,000 minus 7,000. And 10,000 minus 7,000 is 3,000, which is equal to 300 W. Now to get W by itself, divide both sides by 300, divide by 300. W is equal to 30 divided by 3, which is 10 weeks. So after 10 weeks, the cars will have the same number of miles on them. Then moving on to part C. So this part here, these go together. So if we take a look here, it says that how many miles, or M, will the cars have on them when the number of weeks is the same? So use the system of equations from part B to show how we found our answer. So we found that the answer for W was 10. All right, so when the weeks were the same, it was after 10 weeks. So now we need to find out how many miles that is, and that way we do that is we take one of our equations from what we started with. So either M equals 100W plus 10,000 or M equals 400W plus 7,000, and we substitute in 10 for the W, and we'll be able to solve for the M. So I'm going to pick the first one here. M equals 100W plus 10,000. And then we know that our W is equal to 10. So we're going to substitute the W into our equation to find our miles. So we can write M is equal to 100 times 10 plus 10,000. Then M is equal to 100 times 10 is 1,000 plus 10,000. 1,000 plus 10,000, M is equal to 11,000, which is 11,000 miles. So we were able to use our W to solve for our other variable, which was M, and then we have to make sense of our answer, right? It says how many miles will the cars have on them? They will have 11,000 miles on them. All right, let's take a look at question 6. So question 6, starting to get into inequalities. So it says Michelle is a photographer. She sells framed photographs for $100 each. So the photographs, $100 each, and greeting cards for $5 each. So if you want to get a different color there, take a look at greeting cards. Seem to have lost my colors here, for $5 each. The materials for each frame photograph cost $30. So our materials for the photographs cost $30. And the materials for each greeting card cost $2. So greeting card again, $2. Michelle can sell up to 8 frame photographs and 40 greeting cards each week. But this week she has only $200 to spend on materials. So she only has $200 to spend on materials, and she hopes to earn a profit of at least $400 this week. So it says let X be the number of framed photographs. So photographs, wherever we have our pinks, right? That's going to be dealing with our X. And then Y is going to be the number of greeting cards that she'll make. So when we take a look at A, it says write the number on each blank line in the following statement to make it true. So two of the inequalities that model the situation are X has to be less than or equal to. So X is the amount of photographs, and here it says that she could sell up to 8 photographs. So X has to be less than or equal to 8, and Y has to be less than or equal to the number of greeting cards right here, which is where she says up to 40 greeting cards. So it can be less than or equal to 40 greeting cards there. So then it wants us to write 2 more inequalities to complete the system of inequalities, modeling the situation. So the first inequality that we want to write here has to do with how much the materials are and then how much she can spend. So she only has $200 to spend. So at most, she can spend $200. So that's going to be less than or equal to. And then here we want to put how much does it cost for each of her different things here. So a photograph, right? She sells it for $100, but it costs $30 to make. So we're going to say 30 times the number of photographs, right? Plus, then for her greeting cards, they cost $2 a piece, plus 2 times the number of greeting cards has to be less than $200. All right, she can't spend more than $200. But then we want to find her profit here. So when we're looking at the profit, she wants to make at least $400. So now we're talking about greater than or equal to $400. And we want to find the number of photographs that she can sell plus the number of framed or of greeting cards that she can sell in order to make more than $400. So if she sells photographs, she sells them at $100 a piece, right? But she wants to earn a profit of $400. So if we take a look here, the profit on her photograph is the 100 that she sells it for minus the 30 that it costs, which is $70. So for each photograph, she makes $70 because it was sold it for 100 and she paid 30. The next is for the greeting cards. For each greeting card, she sells them for $5, but she has to pay $2 for materials. So to find her profit, we do 5 minus 2, which is 3, so plus 3y. So now we have our two inequalities that we're going to graph, and then the shaded area will represent the solution set. So if we transfer these inequalities over to our page C here, or the other page here. So our first inequality that we're going to graph is 30x plus 2y, which is less than or equal to 20, or 200. Now when we go through and graph this one here, right, we want to solve first for y. So we subtract 30x from both sides, and we get that 2y is less than or equal to negative 30x plus 200. Divide both sides by 2, divide by 2, and we get that y is less than or equal to negative 30 divided by 2 is negative 15x plus 200 divided by 2 is 100. So if we're to graph this one on here, we start at our y-intercept of 100, and then negative 15 means we go down 15 over 1. So we go down 10, 5 for 15 over 1, put a point. Down 15 over 1, down 15. So we're going down a box and a half each time, and then over 1. All right, then we can use our straight edge. And then we can write a solid line here, right, because it's less than or equal to. And then if we're shading y is less than or equal to, we could substitute in our point the origin, right? 0 is less than or equal to negative 15 times 0 plus 100. 0 is less than or equal to 100. So the origin is true for this one. So we're going to shade below. So I'll just mark true here. We'll wait to shade until we graph our second one though. So we take a look at the second inequality. It was 70x plus 3y is greater than or equal to 400. So again, we're solving for y. So we divide both sides, or subtract 70x from both sides. So we have 3y is equal to, or sorry, 3y is greater than or equal to 400 minus 70x. Divide both sides by 3. By 3, divide by 3. And we'll have that y is greater than or equal to, so 400 divided by 3. Which is 133.333, then minus, then 70 divided by 3, which is going to be about 23.3x there, right? So this one doesn't work out as pretty here. All right, so if we're graphing this here, we have a y-intercept of 133. which we'd have to extend kind of our graph up here to see. So I'm just going to extend it up to 110, 120, 130, 140. So we have our y-intercept here, and then we're going down about 23, and then to the right 1. So we go down about 23, to the right 1. Down about 23, to the right, yeah, about here. And as we keep going down, so they gave us a really tough graph to graph. Where they're going to intersect here is going to be at about 3 3/4, and then all the way up to about 45 here. So if you just want to put an intersection point there, it's not pretty. I don't know why the review book did it this way, but for our sake, do that, and then you can create your lines there. So then, if we want to do here, we want to see if the origin is true for this. So 0 greater than or equal to 133.33 minus 23.3 times 0. And that would be that 0 is greater than or equal to 133.33, and that's not correct. So we're not going to shade the origin for our second line, but we will shade it for the first one. So for our first line, when we're shading below our first line. And then for the second line, we're shading above the second line. Which puts our solution set in here where they overlap. So it says Michelle's plans to sell 5 frame photographs and 25 greeting cards. Is that a solution to the system of inequalities? So 5 and 25 is, yes, it is a solution. And because it is in the solution set, yes, it is in the solution set. So it's not the one that would produce the most profit. If we wanted to see how much profit, right, they would produce for this one, we could take 70x plus 3y and see what this is going to equal. So if we substitute in the number 5 frame photographs, so 70 times 5 plus 3 times 25, we'll find this is 350 plus 75, which only equals $425. So while it's greater than, this is greater than the number 400, so it fits the solution, it isn't the highest one. If we want to take a look at one that might be worth a little bit more, if we take a look at the point 6 and 10, so that means that she sold 6 photographs and 10 greeting cards. So if we plug this into our equation here, so 70 times 6 plus 3 times 10, we'll see that she gets a higher profit because 70 times 6 is $420 plus 3 times 10 is 30, and the profit if she sold this solution would be $450, which would be more. So yes, it is in the solution set, but no, does not produce the most profit. So this one's a little messy just because the graph they gave us wasn't great and some of the numbers didn't work out, but we made it through. Question 7, a little bit easier here. So now we're taking a look at Kelly, and Kelly hit a baseball. This is the height of the baseball as graphed. So starting here, so Kelly started at about 5 feet, hit the baseball up to 30, and then it came down and hit the ground at 3 seconds. So how long was the ball in the air? The ball was in the air from the time that it was hit to the time it reached 0 feet, which was 1, 2, 3 seconds. If we need to justify the answer, right, we need to explain 3 seconds because after 3 seconds, the ball was at 0 feet, which would be the ground. Next question here says, how long was the ball more than 20 feet in the air? Justify your answer. So when I'm looking at our graph here, we have 20 feet. So if I draw a line at 20 feet, we want to find out how many seconds was the ball above this line. Well, it started above the line here and then hit the line again here. So we want to find out how many seconds that was. So if we take the second one, which is about 2.5, and we subtract from it 0.5, we can say that it was in the air for 2 seconds. And if we need to justify that, we can say it was going up and past 20 feet at 0.5 seconds, and then came back under 20 feet at 2.5 seconds, which would show that it was up in the air for 2 seconds. Next question here says, when the ball reached its maximum height, what was its average rate of speed in feet per minute? So the average rate of speed in feet per minute. So we want to find out the point that it reached its maximum height and the point that it started and find the average rate of change there. So if we look at our graph, the point where it started, right? So it starts at 0 seconds and 5 feet. So the point where it starts here is 0.5. And then our maximum point here is over 1.5 up 30. So these are our 2 points that we're going to be working with down in part C. So part C, if we want to find the average rate of change, right, we're talking about the change in y over the change in x. So our 2 points were 0.5 and 1.5, 30. So the change in y is that it went from 5 feet to 30 feet. So that's an increase of 25 feet. And then the time it took was 0 to 1.5 seconds for a change of 1.5. So then, if we work this out, 25 divided by 1.5 is going to equal 16 and 2/3 feet per second. Now, the question says, though, what was his average rate of speed in feet per minute? So feet per minute, now we have to change this into feet per minute. So the way that we do that is we take the feet per second, so 16 and 2/3 feet per second. So that's feet per 1 second. And we're going to multiply that by however many seconds there are. So 60 seconds in 1 minute. Then if we take a look at our units, our seconds will cancel out, and we'll be left with 16 and 2/3 times 60. When you multiply on your calculator, 16 and 2/3 times 60. So if we're typing this in here, right, I would do, so 16 and 2/3 is going to be written as 16 plus parentheses 2 divided by 3. And we can hit enter there, just so we can get it as a fraction. Then multiply that answer by 60, and we get our answer of 1,000. We're left with feet, and then we multiply the bottom. 1 times 1 is 1 per 1 minute. So we get our final answer of 1,000 feet per minute. All right, and that's the end of the Module 1 review. If you have questions, make sure you send them out. If you're able to, try and scan these answers in or take pictures on your phone and submit them on Schoology so we can see the good work you've been doing.